BSc Chemistry Surface Coatings presented by Dr. Giridhar M, Assistant Professor of Chemistry, Department of Collegiate Education. So contents. So in this session we will be studying thinners, enamels, emulsifier and special paints. So one is thinners, enamels, extenders, fillers and reinforcers, emulsifying agents, and then special paints. In special paints we will study heat retardant paints, fire retardant paints, eco-friendly paints, plastic paints. So let us start with thinners. So as we have already discussed in our previous sessions that the contents or ingredients of the paints are binders or vehicle, pigment, thinner and dryer, and other added ingredients will be there. So let us see what is thinner. Thinners are diluents. So thinners are also called as diluents or solvents, are used in paints primarily to thin the paint or medium, and should then evaporate from the paint film without leaving a trace. So that means here thinner is used to dilute the paint while painting, and after paint is applied, the thinner should evaporate from the paint, leaving the film unaffected. So this is the definition of thinner. So thinners are used to 1. Reduce the viscosity of drying oil, increase the penetration of vehicle, increase the solubility of certain desirable additives in the vehicle, and then have a desirable consistency for the paint in order to facilitate easy and uniform application of paint on the surface. So these are the applications of thinner. So thinner should be colorless, miscible with the vehicle, should volatilize at a moderate rate and have no effect on the pigment. So it should be colorless, it should be miscible, and also it must be volatile. So these are some of the applications of thinners. So example for thinners are turpentine. Turpentine is well known thinner, okay, which is colorless, which we use in routine. Esters, alcohols can also be used as thinners. Petroleum spirit, aromatic hydrocarbons, so are used as thinners. So turpentine is most commonly used thinner. So it is a cyclic olefin belonging to a general class terpenes. So being unsaturated, terpenes tend to absorb oxygen, polymerize and thicken, forming a film. Terpenes have strong odor and the vapor is physiologically objectionable. So petroleum spirit has no such odor, but low volatile hydrocarbons present in it may leave the film sticky and soft. So turpentine is also one of the thinner. So it will most of the turpentine will evaporate when applying, and the remaining turpentine may absorb oxygen. It may polymerize and thicken, which will help in the drying of the film. So this is about thinners. So let us move to enamels. Enamels are pigmented varnishes. The purpose of preparing enamel is to get a good gloss, because after drying, enamel form a very good lustrous and glossy film. So here enamels are nothing but pigmented varnishes. The purpose of using enamel is to get a gloss finish. Okay, after applying paint, so once the paint dries, it must get a glossy finish. So therefore these enamels are used. Pigments, vehicles, dryers, thinners are used to prepare enamels. They make use of pigments having fine structure and easily dispersible capacity. So example here, so if inorganic okay, pigments are TiO2, calcium sulfate. Extender pigments is used for white enamel. So this TiO2, zinc oxide, all these things are used for white enamel. Okay, calcium sulfate for blue enamel. So such thing. So next, extenders, fillers and reinforcers. So these are inert chemicals like calcium sulfate, barium sulfate, white clay, silica, etc. So these are finely divided solids which are added in small amounts in paints. So why these are added? One, to fill up whites. Second one, to produce lighter tint, to retard setting of the pigment, cast or to act as pigment carriers, to reduce cast, to act as pigment carrier, to act as pigment carriers. So these are some of the applications of, okay, or purpose of using extenders, fillers and reinforcers in the paint. Next we will move to emulsifying agents. So emulsifying agents help to form a emulsion. Okay, emulsifying agents help to form an emulsion. Depending on the type of pigments and vehicles used, different emulsifying agents are chosen. So examples for some of the emulsifying agents are tetrasodium phosphate, sodium laurate, sodium lauryl sulfate, ammonia are some of the examples of emulsifying agent. Heat retardant paints. So special paints, in which first one is heat retardant paint. When the surfaces are exposed to high temperature, so such as chimneys, exhaust pipes, furnaces, oil stills, etc., oil paints tend to decompose or get charred. They are being organic in nature, the surface becomes liable for corrosion. To overcome this problem, heat resistant paints are used. ಸೊ ಅಂದರೆ ನಾರ್ಮಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಪೇಂಟ್ ಯೂಸ್ ಮಾಡಿದರೆ, ಸೊ ತುಂಬ ಹೈ ಟೆಂಪರೇಚರ್ ಇರುವಂಥ ಜಾಗ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಕ್ಸಾಸ್ಟ್ ಪೈಪ್ ಆಗಿರ್ಬೋದು, ಚಿಮ್ನಿ ಆಗಿರ್ಬೋದು, ಫರ್ನೆಸ್ ಆಗಿರ್ಬೋದು, ಇಲ್ಲೆಲ್ಲ ಏನಾಗುತ್ತೆ, ಸೊ ಬರ್ನ್ ಆಗುತ್ತೆ ಆ ಪೇಂಟು, ದೇ ವಿಲ್ ಗೆಟ್ ಚಾರ್. ಸೊ ಹ್ಯಾಂಡ್ಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಡೂ ಇಸ್, ನಾವು ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ heat retardant or heat resistant paints. So even at high temperature, this paint remains stable. So heat resistant paints are paint withstand high temperature, even up to red hot. Okay, even if the metal goes up to red hot temperature, still the paint withstands that heat. So they contain base metal powders like aluminum, zinc, essence, stannum, tin, graphite, titania, chromia, etc. So some heat resistant paints contain polyphenol silicones such paints are also water repellent. So usually content ಏನಾಗಿರುತ್ತೆ, ಅಲ್ಯೂಮಿನಿಯಂ, ಜಿಂಕು, ಟಿನ್ನು, ಗ್ರಾಫೈಟು, ಟೈಟಾನಿಯಾ, ಕ್ರೋಮಿಯಾ, ಸೊ ಇವೆಲ್ಲ ಆಗಿರುತ್ತೆ. ಅದೇ ರೀತಿ ಕೆಲವು ಪೇಂಟ್ಸು ಪಾಲಿಫಿನೈಲ್ ಸಿಲಿಕೋನ್ಸಿಂದ ಕೂಡ ಮಾಡಿರ್ತಾರೆ, ಆ್ಯಂಡ್ ದೇ ಆರ್ ವಾಟರ್ ರಿಪೆಲೆಂಟ್. ದ ಟಿಪಿಕಲ್ ಕಂಪೋಸಿಷನ್ ಆಫ್ ಹೀಟ್ ರೆಸಿಸ್ಟೆಂಟ್ ಪೇಂಟ್ಸ್ ಆರ್ ಲ್ಯಾಂಪ್ ಬ್ಲ್ಯಾಕ್ 3 kg, ಗ್ರಾಫೈಟ್ 3 kg, ಬ್ಲ್ಯಾಕ್ ಆಕ್ಸೈಡ್ ಮ್ಯಾಂಗನೀಸ್, ಓಕೆ, ಮ್ಯಾಂಗನೀಸ್, ಬ್ಲ್ಯಾಕ್ ಆಕ್ಸೈಡ್ ಮ್ಯಾಂಗನೀಸ್ 1 kg, ಜಪಾನ್ ಗೋಲ್ಡ್ ಸಿಂಕ್ 1 liter, ಟರ್ಪಂಟೈನ್ 1.5 liter, ಬಾಯ್ಲ್ಡ್ ಲಿನ್ಸಿಡ್ ಆಯಿಲ್ 1 liter. So this is one example for one type of heat resistant paint, and the compositions are given. Paint suitable for space technology has been developed by NASA. It can withstand temperature from -150 to 1000 degrees centigrade. So it contains titanium oxide pigment, water solution of an alkali metal silicate which is used as vehicle, aluminum orthophosphate which is used as wetting agent, and water as thinner. So this is also one example for heat resistant paint which is prepared by NASA. So uses, such paints are used to finishes of ovens, furnaces, oil stills, aircraft combustion chambers, diesel engines, etc. Next, Next, fire resistant paint. So we have studied heat retardant paints, now fire resistant paints. So these are paints containing chemicals which are fire resistant in nature. In other words, they produce gases on heating which are themselves non-combustible and do not support combustion, thereby minimizing the rate of burning or exhausting the fire. So ಇಲ್ಲಿ heat retardant ಅಂದರೆ, so heat retardant paints ಏನು ಮಾಡುತ್ತೆ, so they will become stable even at high temperature. But ಇಲ್ಲಿ fire retardant paints ಅಂದರೆ, so even fire ಆದರೂ ಕೂಡ this paint does not burn in fire. ಸೊ ದೋಸ್ ಆರ್ ಕಾಲ್ಡ್ ಫೈರ್ ರಿಟಾರ್ಡೆಂಟ್ ಪೇಂಟ್ಸ್. ಬೆಂಕಿ ಹಚ್ಚಿದ್ರು ಕೂಡ ಬರ್ನ್ ಆಗಬಾರ್ದು ಅಂಥ ಪೇಂಟ್ಸ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಫೈರ್ ರಿಟಾರ್ಡೆಂಟ್ ಪೇಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಫೈರ್ ರೆಸಿಸ್ಟೆಂಟ್ ಇನ್ ನೇಚರ್. ಓಕೆ, ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇನ್ ದಿಸ್ ಫೈರ್ ರೆಸಿಸ್ಟೆಂಟ್ ಪೇಂಟ್? ದೇ ಪ್ರೊಡ್ಯೂಸ್ ಗ್ಯಾಸಸ್ ಆನ್ ಹೀಟಿಂಗ್. ಓಕೆ, ಗ್ಯಾಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಹೀಟ್ ಆಗ್ತಿದ್ದಂಗೆ, ಆ್ಯಂಡ್ ದೀಸ್ ಗ್ಯಾಸಸ್ ಆರ್ ನಾನ್ ಕಂಬಸ್ಟಬಲ್. ಓಕೆ, ನಾನ್ ಕಂಬಸ್ಟಬಲ್ ಆ್ಯಂಡ್ ದೇ ಮಿನಿಮೈಸ್ ಬರ್ನಿಂಗ್. Okay, so this is the mechanism of this fire retardant paint. Say for example, ಒಂದು ಪೇಂಟ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಂಡು ಆ ಪೇಂಟ್ ಬೆಂಕಿ ಹಚ್ಕೊಂಡಾಗ ಬಿಲ್ಡಿಂಗು, ಆ ಪೇಂಟಲ್ಲಿ ಏನೋ ಒಂದು ಕಂಟೆಂಟ್ ಇದೆ, ಆ ಕಂಟೆಂಟ್ ಬರ್ನ್ ಆಗಿ ಇದ್ದೇ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಆ್ಯಸ್ ವಿ ನೋ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಈಸ್ ಎ ಗುಡ್ ಫೈರ್ ಎಕ್ಸ್ಟಿಂಗ್ವಿಷರ್, ಸೊ ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಇನ್ ಮಿನಿಮೈಸಿಂಗ್ ದಟ್ ಎಫೆಕ್ಟ್ ಆಫ್ ಫೈರ್. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ದ ಡಬಲ್ ಫಾಸ್ಫೇಟ್ಸ್ ಆಫ್ ಅಮೋನಿಯಾ ಲೈಕ್ ಕ್ಯಾಲ್ಶಿಯಂ with Ca2 plus Mg2 plus Zn2 plus etc. produce ammonia by decomposition. Okay, ammonia by decomposition. Calcium carbonate and calcium bicarbonate produce carbon dioxide and getting heated. So antimony oxychloride forms HCl with moisture. So now if you take ammonia or carbon dioxide or HCl, all these are fire retardant gases. So silicon paints are also used as fire retardants. Next we will move to eco-friendly paints. So eco-friendly paint or natural paint is a paint that has been specially designed to have lower levels of volatile organic chemicals. So ಅಂದರೆ ಇಲ್ಲಿ volatile organic chemicals ಕಡಿಮೆ ಇರುತ್ತೆ. Okay, volatile organic chemicals ಯಾವುದು? So like terpenes, okay, terpenes, turpentine, alcohols, ethers, all these are volatile organic chemicals. VOCs may have short and long-term adverse health effect, and while people are using products containing organic chemicals, they can expose themselves and others to very high pollutant levels, and elevated concentration can persist in the air after the activity is completed. So for example, thinner ಲೈಕ್ ಟರ್ಪೆಂಟೈನ್ ನಾವು ಯೂಸ್ ಮಾಡಿದರೆ ಪೇಂಟ್ ಡ್ರೈ ಆಗಬೇಕಿದ್ರೆ ಆ ಟರ್ಪೆಂಟೈನ್ ಎವಾಪ್ರೇಟ್ ಆಗುತ್ತೆ. ಎವಾಪ್ರೇಟ್ ಆಗಿ ಗಾಳಿಯಲ್ಲಿ ತುಂಬ ಹೊತ್ತು ಇರುತ್ತೆ. ಸೊ ಉಸಿರಾಡೋರಿಗೆ ಅದರಿಂದ ಏನಾಗುತ್ತೆ, ತೊಂದರೆ ಆಗುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಎಕೋ ಫ್ರೆಂಡ್ಲಿ ಪೇಂಟ್ಸಲ್ಲಿ ಈ ವಾಲಟೈಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಕಲ್ಸ್ ಅಂತ ಏನಿದೆಯಲ್ಲ, ಸೊ ಅದನ್ನು ರೆಡ್ಯೂಸ್ ಅಥವಾ ಮಿನಿಮೈಸ್ ಮಾಡಲಿಕ್ಕೆ ವಿ ಟ್ರೈ, ಆ್ಯಂಡ್ ಸಚ್ ಟೈಪ್ ಆಫ್ ಪೇಂಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಎಕೋ ಫ್ರೆಂಡ್ಲಿ ಪೇಂಟ್. So environment friendly paints are made from variety of natural materials including clay, milk protein, citrus, okay, balsam and other minerals. So these are some how this environment friendly paints are made. So for example, protein alli casein anta ide. So you can observe casein, okay, paint in casein paint is available. So one example is milk paint, which is made from milk proteins such as casein and little lime. So milk paints have been used for hundreds of years and usually come in powder form. So when mixed with water before use, it emits little or no odor. Since eco-friendly paints are low in VOC chemicals, they are much safer to use in your home. So eco-friendly paints are classified into three types. So one, zero volatile organic compounds, that is total VOC content is less than 5 gram per liter of paint. Second one, low volatile organic compounds, so total VOC content is from 5 to 200 per liter of paint. So natural paint made up of natural compounds such as tree resins, water, plant oil, essential oil and natural dyes do not contain, any of these natural dyes do not contain VOCs. Next we will move to plastic paints. So an emulsion paint which contains a higher proportion of plastic is commonly known as plastic paint. So it is based on acrylic, which has been tendency to give smooth matte finish to the walls. As the quantity of plastic rises in the paint, we can see a higher amount of smoothness and silky finish after application. So ಅಂದರೆ ಈ ಪೇಂಟಲ್ಲಿ ಪ್ಲಾಸ್ಟಿಕ್ ಇರುತ್ತೆ. ಸೊ ಪ್ಲಾಸ್ಟಿಕ್ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಗಿವ್ ಸ್ಮೂತ್ ಫಿನಿಶ್. ಓಕೆ, ಯೂಶಲಿ ದೀಸ್ ಆರ್ ಅಕ್ರೆಲಿಕ್ ಬೇಸ್ಡ್ ಪೇಂಟ್ಸ್. ಓಕೆ, ಆ್ಯಂಡ್ ದೇ ಗಿವ್ smooth finish to the surface. So benefits of plastic paints are: 1. Plastic paints are less toxic and hence odorless. They have always helped the paint to work with ease as they are easy to apply. Even though a person will paint the supreme paint available in the market, still they will choose plastic paint, which is ideal for toilets and ceiling. A plastic paint can be painted on wood, glass, concrete and metal surfaces. The outcome of plastic paint is much smoother. Bright plastic paint brightens up the dark room, whereas sunlight is minimum. Stains and dust are easy to clean using a wet cotton cloth. Plastic paints do not crack even when they are fully exposed to sun. So these are some of the applications of plastic paint. So these are references. Thank you.